Assalamu alaikum. Hello viewers. Today I am going to discuss with you some problems for differentiation and limits. Here I first will show you some definition and formulas from these topics. First of all, the what is gradient? The gradient of a straight line from a point P x1 y1. x1 y1 is the coordinate of the point P, and x2 y2 is defined as y2 difference between y coordinate and divided by difference between x coordinate, which is y2 minus y1 divided by x2 minus x1. And then what is the tangent? When a line touches a curve without cutting through it, then the line is said to be the tangent to the curve. Here then it is a first principle of differentiation. Here you can see a curve here, which is the curve of y equal to x square, where this is x axis and it is y axis, and on this curve y equal to x square there are 2 points P and Q. Let Pxy be a point on curve y equal to x square, and then coordinates of Q is x plus delta x and y plus delta y. Here the point P xy lies on the curve y equal to x square. I gave this equation a number, which is equation 1, and then the Q with which is x plus delta x and y plus delta y lies on the same curve. Then we can put this point on this equation. Then we get y plus delta y is equal to x plus delta x whole square, and here if we apply a plus b whole square formula, then we get a square plus 2ab plus b square. By subtracting equation 1 from equation 2, we get delta y. Value of delta y is 2x delta x plus delta x whole square. Since we when we subtract, the term x square and x square will cancel, and the remaining part is 2x delta x plus delta x whole square. Now from the figure I show before, there qr is equal to 2x delta x plus delta x whole square, and pr is equal to delta x, and then the gradient of pq will be qr by pr, which is delta y by delta x, and the value of delta x is delta y is 2x delta x plus delta x whole square divided by delta x, and if we divide the numerator separately, then we get 2x plus delta x. So the value of gradient of pq will be 2x plus delta x. Now as q approaches p, we see that the point on the curve here, q lies on here and p lies on here. If the distance between pq decrease, that means if q approaches p, what will happen? That is, we are going to show. We are going to find that when q approaches p, that means delta x tends to 0, and as q tends to p, the gradient of pq will be limit delta x tends to 0 and then delta y divided by delta x, and when limit delta x tends to 0, the value of delta y by delta x we got before, which is 2x plus delta x, and here if the delta x tends to 0, the value of this function will be 2x. Here this notation as delta x tends to 0 is called the derivative of y with respect to x. Here the limit delta x tends to 0 and delta y by delta x is defined as dy by dx. Thus dy by dx measures the rate of change of y with respect to x. Now here actually we I have shown you the first principle. This is called the first principle, where we take a small change of the coordinates x and y coordinate, then we get the gradient of the line, or gradient of the tangent, which is pq, and then we find the definition of dy by dx, which measures the rate of change of y with respect to x. Now we are going to solve some problems from limit. uh, Before discussing about the problems of limit, I am going to show you some basic problems. What is limit actually? If it is a function f of x is equal to x square minus 9 divided by x minus 3, and what will be the value of this function at x is equal to 3? If we put the value of x is 3, then we get 0 at the denominator, which is meaningless. 0 by 0 is meaningless. This and there are many meaningless, like 0 by 0, infinity by infinity. This meaningless type fraction is called the indeterminate. So for this type of function, we can't find the value, so we have to use the concept limit. What is limit? Let's see, if we put the value of x close to 3, which is 3.1, 3.01, the value of the function will be close to 6. Thus we bring the concept limit here, which is if x approaches 3, the function approaches the value 6, and it is we write this by like this way, which is limit x tends to 3, f of x is equal to 6. And in general, limit x tends to a, when x tends to a, the value of f of x will be m. Now we are going to solve some problems. Here this is our function, and limit is tends to infinity. First we take the x cube outside of a bracket, then in the bracket we get 2 minus 6 by x plus 4 by x square minus 7 by x cube, and in the similar way we get x cube outside of the bracket, and in the bracket we get 3 by x cube minus 4. And when x tends to infinity, in the numerator we get 2 minus 6 by x plus 4 by x square minus 7 by x cube, and denominator we get 3 by x cube minus 4. Here if the value of x is infinity, we get this term is 0. That's why this term all will be 0, also this term. Notice here that we can write this, we can write x is equal to infinity here, because that will be logically wrong, because we can take the value of x is infinity. It is near to infinity, but we can put the value of x is infinity, right? We can guess that what will be the value of the function when x tends to infinity. So like the value of function will be minus half. And for the second problem, this is our function. First we have to multiply the numerator, and then we get x square minus 5x minus 4x plus 20, and in the denominator x square minus 7x plus 6 minus 7 plus x minus 7. Then we similar way, we take x square outside a bracket, and thus we get the value of the function is 1. Then this is a little different math. Given function here, x cube minus 27 divided by x minus 3, and x tends to 3. Here we apply the formula a cube minus b cube, which is a minus b into a square plus ab plus b square. We can cancel x minus 3 from the numerator and denominator, and the remaining part is x square plus 3x plus 9. And when we again notice that we can put the value of x 3, we have to calculate in our mind or in the rough that what will happen if the value of x is 3. But we can show the calculation here, which is a 3 square plus 3 times 3 plus 9. We have to calculate in our mind or in the rough page. So what will happen if the value of x is 3 square plus 3 times 3 plus 9, which is 27, right? Now again, the next problem, limit x tends to 0. Here is our function. First we have to apply a minus b whole square formula, which is x square minus 2 plus 1 by x square minus 2x minus 1 by x square. Now we get x square minus 2x minus 2, and when what will happen if x is equal to 0, which is minus 2, right? So this I tried to show you some difficult problems from limit. Now I'm going to show some problems from differentiation and gradient. Here we have to differentiate this function from according to the first principle. The given function is y is equal to 5 by x square plus 2. According to first principle, we have to increase, we have to take a small increment of x and also a small increment of y. We have to take both increment of a small increment of the coordinates, right? So y plus delta y is equal to 5 by x plus delta x whole square plus 2, and by subtracting 1 from 2 we get delta y is equal to 5 by x plus delta x whole square minus 5 by x square. And here if we add this in the denominator, we get x plus delta x whole square x square, if after adding this we get minus 10x minus 5 delta x divided by x square times x plus delta x whole square, which is the value of delta y by delta x. Similar way, now we have to find the limit. What will happen if delta x tends to 0, right? When delta x tends to 0, if we use the limit, which is limit delta x tends to 0 del y by delta x, the value of delta y by delta x we find before, which is minus 10x minus 5 delta x divided by x square times x plus delta x whole square. If the value of delta x is 0, then this part will be 0, and this part, from this part we get x square. Now the value of dy by dx will be minus 10 by x cube, right? So for the first principle, remember we have to bring a small increment of the coordinates, then we have to find this the value of del y by del x, and then we have to apply the limit, right? We have to take the steps are we have to take the small increments of the both x and y coordinates, then we have to find the value of del y by del x, and on this we have to apply the limit. By applying limit we get the value of dy by dx. Now we have to see some more formula techniques for solving differential problems from differentiation, which is if y is equal to ax to the power n, then dy by dx will be an times x to the power n minus 1, where a is a constant and n is an integer or a rational number. And for a curve y is equal to fx, dy by dx represents the gradient of the tangent to the curve at any point x, and also d by dx u plus v will be du by dx plus dv by dx. Now we are going to solve some problems. Here we have to find the gradient of the curve y is equal to root over x plus 1 by root over x at the point, right? We have to find the gradient. Here the function is y is equal to square root of x plus 1 by square root of x. We know square root is half, that means x to the power 1 by 2, and similar way 1 by x to the power half. 1 by x to the power half means x to the power x to the power minus half, right? And the value of dy by dx will be half x to the power half minus 1 minus half x to the power minus half minus 1. So here the value is half x to the power minus half, because 1 by 2 minus 1 is equal to minus half, right? A similar way, if we apply, if we do the LCM here, minus half minus 1, if we take minus in the bracket, it will be half plus 1, so this is 3 by 2, which is minus 3 by 2. In the similar way, half minus 1, half minus 1, this that will be, if we do the LCM here, 1 minus 2, that is minus 1 by 2. So at this point the gradient will be, we have to put the value of x, which is 4, and if we apply the square root here, this will be 1 by 4, and here it will be 1 by 16. How it is here, if we, for this we can write 1 by, right, and for this we can write 1 by 4 root 4, right? So this will be 2 times 2, 1 by 4, and here 2 times 4, 8, and 8 times 2, 1 by 16, right? So and we say, when we apply the LCM here, 4 minus 1, which is 3 by 16. So this is the gradient. Now for this problem, we are saying that the straight line meets the curve xy plus 10 is equal to 0 at the points pq. We have to calculate the gradient of the curve at p and q. Here we are given that xy plus 10 is equal to 0, and the value of y will be minus 10 by x. This is equation 1, and for equation 2, 2x plus 3y is equal to 7, which is equation 2. We have to substitute the value of y in by this equation. We have to substitute the y in equation 2 by this, right? So 2x plus 3 times minus 10 by x is equal to 7, and if we multiply both sides of the equation by x, then we get 2x square minus 7x. No, we find a 7x by after calculation, like 2x square, this term will be minus 30, right? And this will be 7x, right? When we multiply both sides of this equation by x, this term will be 7x, right? And if we bring the 7x to the left hand side, and we get minus 7x. Okay, now we apply the middle term. We have to break this term into two. How? First we multiply 2 times 3, 2 times 30 is 60, and if we factor if we find the factor of 60, we get 12 and 5, and here we get the value of x is x6 and minus 5 by 2, and for this value we get the value of y here, minus 5 by 3 and 4, and we get the value of p and q, two coordinates, and for these two coordinates we have to find the value of the gradient, because we have to calculate the gradient at this point, and first we find the coordinate, then and now we calculate the gradient. So for the equation, from equation 1 we know y is equal to minus 10 by x, and equation of the gradient will be dy by dx. We know that the formula ax to the power n, if y equal to x to the power n, our dy by dx will be a n x to the power n minus 1, right? So we have to apply this here, minus 10 minus 1 x to the power minus 1, which is 10 by x square, and for at p the dy by dx will be, by calculating we get 8 by 5, and at q we find the value 5 by 18. Actually these problems I tried here, in this problem I tried to show you some critical problems from limits and differentiation, and for that I follow these books, pure mathematics from uh, uh, IJCAC curriculum. They follow these books for pure mathematics. If you have any more problems, if you think anything which is difficult, any topic which is difficult, you can post a comment in my YouTube channel, and also message me Please support me and subscribe my channel. It will motivate me more to create more useful video for you. I hope you all the best. Take care of yourself. Thank you. Thank you everyone.